three problems. Okay, there are a few more problems that we will complete today. Okay, let me go to fourth problem. Yes, please note this fourth problem. All of you note this fourth problem. So these are all very simple problems. All the guidelines are there in the codebook only. Only you must remember the procedure of solving the problem. Okay. Sorry, this is of second model. No? Let me open the fourth problem of third model. Yes. Note this problem. So we have solved up to problem number 3. Okay. Up to problem number 3 we have solved. Okay. Just go through it. A post-tension beam with unbonded tendons. Okay, very important. The condition given is unbonded tendons, which means that we have to refer table 12. Okay, table 12, not the table 11. Here you can see for unbonded tendons we need to refer table 12. Okay, table 11 is for the tendons having effective bond. Okay, tendons having effective bond. Okay, is of rectangular section B and D is given. B is given as 500 mm. Okay, let me write the diagram. B is equal to 500 and effective depth D is equal to 1000 mm. It is given. Okay, and very important, he has given that the beam is with unbonded tendons. Okay, and it is a post tensioned beam. Correct. So it is the condition given is post tensioned unbonded tendons. Unbonded tendons, which means we have to refer table 12. Okay, of page number 60. Okay, then cross-sectional area of the pre-stressing steel is given. That is AP. Cross-sectional area of pre-stressing steel, it is given as 3000 mm square. Then effective pre-stress after considering all losses is 1000 MPa. Effective pre-stress after considering all losses is equal to FPE. It is given as 1000 MPa, 1000 Newton per mm square. Okay. Then effective span of the beam made of M40 concrete is 15 meter. Effective span is given 15 meter and grade of concrete FCK is given as 40 MPa, 40 Newton per mm square. Then estimate the ultimate moment of resistance of the section using codal provisions. Okay. Now we have the formula for finding the moment of resistance of rectangular section in the page number 59 here, correct? M is equal to FPU into AP into D minus 0.42 XU. Okay. Now write from page number 59 IS 1343 1980. We have the formula for finding moment of resistance. MU is equal to, what is the formula? FPU into AP into D minus 0.42 XU. FPU into AP into D minus 0.42 XU for rectangular section. Okay. Where FPU is ultimate tensile stress in the tendon, AP is area of pre-stressing steel, D is effective depth, and XU is depth of neutral axis. Okay. And values of this FPU, ultimate tensile stress in the tendon and depth of neutral axis, are obtained by using this table 12. Okay, table 12. Okay, using the rectangular beams having unbonded tendons. Using this table, we need to obtain the value of FPU, and FP means we will get the ratio of FPU to that of FP and XU by D. If we get this ratio, we can work out for this FPU and XU, correct? As we practiced for previous problems. So to obtain this FPU, AP, we need the value of this ratio, that is AP divided by BDFCK, and we also need the ratio of effective span to effective depth. Okay, now we'll work out the values for AP FP by BDFCK and L by D ratio. Okay, now the ratio AP FP by BDFCK. Okay, which is nothing but AP into, here in this problem, effective pre-stress after considering the loss is given, you take the same value only, FPE only. FPE divided by BDFCK. Okay. Now area of pre-stressing steel, how much it is? Area of pre-stressing steel is given as 3000 mm square. Area of pre-stressing steel is 3000 mm square. Therefore 3000 into FPE. FPE is 1000 MPa into 1000 divided by BDFCK. B is 500, D is 1000, FCK is given as 40. Okay, please solve this. Please solve this and get the answer. Please check your answer. It has to be 0.15. Let me know if you are getting any other different answer. Okay, now we got the value of this ratio. Then what else is needed to calculate this FPU by FP and XU by D ratio? We need this effective span to effective depth ratio, L by D ratio. Effective span to effective depth. Effective depth is equal to L by D is equal to 15 meter is the length of the beam given, correct? In terms of mm, it is 15,000 mm, means 15 into 1000 divided by effective depth is given as 1000 mm. So ratio will be how much? It will be 15. The ratio will be 15. Okay. Now corresponding to AP, FP by BD, FCK is equal to 0.15 and L by D ratio is equal to 15. We have to obtain the FPU by FP value and XU by D value. Okay. So what is the value of AP, FP by BD, FCK? It is 0.15. It is 0.15. Here we have that value. Here we have that value. Then what is the L by D ratio? We got L by D ratio, we got it as 15. L by D ratio 15 we got. So for 15 we don't have the value. Here we have the value for 10. We have the value for 20. So we can, by interpolation, we can obtain the value for 15. Okay. Similarly, for obtaining XU by D ratio, here we have 0.52 as 52 for L by D ratio is equal to 10 and 0.46 for L by D ratio is equal to 20, and you can obtain the value for L by D ratio of 0.15. Okay. Now below you write from table page number 60. Okay. So it is page number 60. Okay. From table 12. From table 12. Page number 60. Okay. For AP, FPE, BDFCK is equal to 0.15. Okay. Now you pick up these two values. Okay. For L by D is equal to 10. The FPU by AP value is 1.36. For L by D ratio is equal to 20. FPU by AP is equal to 1.20. Let me write the same thing here. For L by D is equal to 10, corresponding FPU by FP is equal to 1.36, and for L by D is equal to 20, corresponding FPU by FPE is equal to how much it was? 1.20. 1.20. Now for L by D is equal to 15. You need to obtain the value of FPU by FPE. Okay. Now you can do the interpolation, or else you can directly take the average, because 15 is the average of 10 and 20. So the corresponding value will be average of this 1.36 and 1.20. Or else you can perform the interpolation. Okay. After interpolation, you will get the value of FPU by FP as, please do the interpolation and check your answer. It is 1.28. Okay. 1.28. Now FPE is now, what is the value of FPE? It is 1000. Substitute that here. FPU by 1000 is equal to 1.28. Therefore, FPU is equal to 1280 Newton per mm square. Now you got the value of FPU. Now what else is remaining? You need to get the value of XU. Okay. Now refer this table. Okay. Same thing for L by D is equal to 10, value is 0.52, for L by D is equal to 0.46. Okay, XU by D value is equal to for L by D is equal to 20, XU by D is equal to 0.46. Do the interpolation and get the value for 15. Okay, and for AP FPE divided by BDFCK is equal to 0.15. For L by D is equal to 10, corresponding XU by D is how much it was? 0.52 and 0.46. 0.52, and for L by D is equal to 20, corresponding XU by D is equal to 0.46. But we want the value for L by D is equal to 15. D is equal to question mark. Now do the interpolation or take the average. After interpolation, you will get the value of XU by D is equal to 0.49. Please check the answer. 0.49. Effective depth is known. Just substitute XU by 1000 is equal to 0.49. By this you will get the value of depth of neutral axis. Okay, you will get the value of depth of neutral axis as 490 mm. 490 mm. Okay. Now XU is known, FPU is known, everything is known. You can get the value of moment of resistance. Therefore, moment of resistance ME is equal to therefore moment of resistance MU is equal to FPU is 1000. How much we got? 1280. 1280 into AP. AP area pre-stressing steel. How much? Area pre-stressing steel is 3000. 3000 into D minus 0.42 XU. 1000 minus 0.42 into 490. Okay, by this we'll get the answer as 3.049 into 10 power 9 Newton millimeter, or 3000. So you can rewrite this as 3049 into 10 power 6, which in terms will be 3049 kilonewton meter. Okay, this completes the problem. Very simple problem. Okay, everything is there in the code book. Okay, this formula is there. Even the table is there to pick up the value of FPE and XU. You can easily solve the problem. Correct? So any doubts in this particular problem, you can ask students before moving on to the next problem. Thank you. All of you note this fifth problem quickly. Take 1 or 2 minutes time to note the problem. I hope everyone is writing the problem. Okay, we'll start solving. What is the problem here? It is problem on I section. Pre-tensioned. Okay, it's a pre-tensioned beam. Means it belongs to table 11. PSC beam of I section with 160 by 70 flanges with thickness of 50 mm and overall depth of I section is 320 mm. Let me write the diagram. Okay, all dimensions are given. I'll write the diagram. One 60 by 70 flanges. Okay, 160 is the width of the flange. 160 is the width of the flange. And 70 is the depth of the flange. With thickness of a web 50 mm. Web thickness is given as how much? 50 mm. Overall depth of I section is 320 mm. Overall depth of the I section is 320 mm. Okay. The beam is pre-stressed with 4 high strength steel wires. 4 high strength steel wires of 7 mm with an effective depth of 265 mm. Effective depth is given. Effective depth D is equal to 265 mm. 265 mm. Okay. Then FCK and FP is given. Find the ultimate flexural strength. Same here also we have to find ultimate flexural strength. Okay. Now the main condition is given as it is a pre-tension beam. Pre-tension beam means it belongs to table number 11. Pre-tensioned beam, which means refer table 11. Then all dimensions, sectional dimensions of the I section is given. Okay. Then he says that the beam is pre-stressed with 4 high strength steel wires of 7 mm at an effective depth of 265 mm. Okay, there are 4 number of bars having dia 7 mm. You can find the area of pre-stressing steel. Area of pre-stressing steel is equal to AP is equal to, there are 4 number of bars having 7 mm diameter. Pi d square by 4 into this area of 1 bar into 4 number of bars will give total area of pre-stressing steel, that is 154 mm square. 154 mm square. Okay. Then what else is given? FCK and FP is given. FCK is given as 50 Newton per mm square. FP is given as 1600 Newton per mm square. FCK is equal to 50 Newton per mm square and FP is equal to 1600 Newton per mm square. Okay. Now, as this is a flanged section, okay, I section, we don't know about the location of the depth of neutral axis, whether it is lying in the flange, whether it is lying in the web, we don't know. Okay, so we have to make an assumption. Okay, any one of the assumption, and we have to check whether assumption is correct or not. If assumption is correct, then we have to solve for moment of resistance accordingly with respect to assumption. Otherwise, if the assumption goes wrong, then we have to assume alternatively. It means if you assume depth of neutral axis lying in the plane, then depth of neutral axis will be lying in the web, and vice versa. And we have to proceed for solving moment of resistance. Okay. Initially, we will assume that the depth of neutral axis lies within the flange only. Okay. Step one. Step one. Step one. Depth of neutral axis. Okay. We will find where the depth of neutral axis is lying exactly. Now for that, we assume neutral axis lies within flange. Okay, that is, what is the flange thickness given? 70 is the flange thickness given. So depth of neutral axis is less than or equal to 70 mm. This is the assumption we made now. Now, assuming depth of neutral axis lies within the flange, we will find the ratio XU by D. XU by D ratio we will find. Then knowing XU by D ratio, you will get the value of XU. Then we can decide whether the depth of neutral axis is lying in the flange or not. Correct? Now, from table 11, okay, from table 11, we have to find the ratios AP by BDFCK and FPU by 0, and BDFCK ratio we need to find, and corresponding XU by D ratio we can obtain. First we will find this ratio AP by BDFCK. Okay, from table 11, from table 11 APFP by BDFCK, which is equal to, so here we have assumed that depth of neutral axis lies within the flange. So here this formula should be rewritten as APFP divided by width of flange to DFCK. Okay. So when you assume depth of neutral axis lies within the flange, you need to take width of the flange. When you assume neutral axis lies within the web, then you need to take BW, width of web. Okay. So AP, just now we have determined 154 area of pre-stressing steel. FP is 1600 divided by width of flange. How much it is? 160 mm. 160, and effective depth 265 mm. 265 mm. FCK is given as 50 Newton per mm square. Please solve this ratio and check the answer. It is 0.116. 0.116. Now corresponding to this ratio, you have to find this XU by D. Okay, means we have to refer this pre-tensioning column type of PSC beam given is pre-tensioned beam it is. So you need to refer this column. Now AP, FP by BD, FCK, how much we have? 0.116. 0.116 means it will come in between 0.15 and 0.20. For 0.15, the corresponding XU by D is 0.326. For 0.20, corresponding XU by D is 0.435. You need to solve for 0.116. 0.116, no? Oh, sorry. It is 116 means it will fall between 0.1 and 0.15. 0.1 and 0.15. For 0.1, the value of XU by D is 0.217. For 0.15, value of XU by D is 0.326. Take these values and solve for 0.116. Okay. Therefore, from table 11, page number 59. Okay. For AP, FP by width of flange into DFCK is equal to 0.10. Okay. Corresponding XU by D is equal to how much it is? 0.217 and 0.326. 0.217. Okay. For 0.15, corresponding XU by D is equal to 0.326, and we want the value for 0.116. Just do the interpolation, you'll get the answer. After interpolation, XU by D value will be equal to, you will get it as 0.252. Please check the answer, cross check the answer. 0.252. XU by effective depth is given as 265 is equal to 0.252. By this we'll get the depth of neutral axis. XU is equal to 66.78 mm. Now you compare this depth of neutral axis with that of depth of flange. Depth of neutral axis is 66.78 mm, but depth of flange is 70 mm. So depth of neutral axis lies within the flange only, which is 66.78 mm, which is less than DF, which is 70 mm. Therefore, assumption is correct. Okay, hence the assumption is correct. Okay, our assumption is correct because depth of the neutral axis lies within the flange. Now you find a corresponding FPU by 0.87 FP value. Okay, with respect to the BD AP FP divided by BD FCK 0.116, you will get that value as 1 only. Okay, because for 0.1 value is 1, for 0.15 value is 1, so you will get the same value for 0.116. Okay, from table 11. Table 11 for AP FP by BD FCK is equal to 0.116 corresponding FPU by 0.87 FP is equal to 1.0. Okay, now substitute the value of FPU divided by 0.87, FP is given as 1600 is equal to 1.0. We will get the answer of FPU as 1392 Newton per mm square. 1392 Newton per mm square. Okay, now you can utilize the formula of mu APU into AP into D minus 0.42 XU. Okay, this formula is applicable only when depth of neutral axis lies within the flange. If the depth of neutral axis lies within the web, what is the formula which we have to use? Let me go to the theory part. This is the formula which we have to use for depth of neutral axis lies within the web. Okay, here depth of neutral axis lies within the flange, same formula. Okay, which is given in codebook. Okay, moment of resistance, therefore moment of resistance formula when or since within the flange, within the flange, within the flange, the formula for mu will be same formula which is given in the codebook, that is FPU into AP into D minus 0.42 XU. Okay, page number 59, 1383. Okay, now everything is known. Just substitute and get the answer. Therefore, mu is equal to FPU. How much we got? 1392 into AP, area of resisting steel, 154. 154. Effective depth is 265 minus 0.42 into XU. How much we got? 66.78. 66.78. Okay. Therefore, mu is equal to 50.79 into 10 power 6 Newton millimeter, or mu is equal to 50.79 kilonewton meter. Okay. To this, this problem is completed. Very simple procedure. Okay. If any doubts, you can ask. Thank you. Right. Problem number 6 now. Quickly. Right. Problem number 6. Okay. We start solving this. So it is the problem on an unsymmetrical I section. Okay, just go through it. An unsymmetrical I section. Bridge girder has the following sectional properties. Width and thickness of top flange is given 1200 by 360. Then thickness of web is given, centroid of the section is given. Let me write the unsymmetric I section now.
Sir, unmute, sir.
Oh, sorry. Okay. Just go through the problem. I have written the diagram. An unsymmetrical I section bridge girder has the following sectional properties. Width and thickness of top flange is 1200 by 360. 1200 by 360 is the sectional dimensions of the top flange. Then thickness of the web is given as 240 mm. Okay, 240 mm thickness I have mentioned here. Centroid of the section is located at 580 mm from top. Okay. Okay. And he says that the distance of centroid is located at a distance of 580 mm from top fiber. That also I mentioned. The girder is used over a span of 40 meter. Length of the beam or length of the girder is given. It is given as 40 meter. Nothing but 40,000 mm. The tendons are unbonded with the cross section 7,000 mm square. Area of pre-stressing steel area of tendon is given. AP is given as 7,000 mm square. Okay, and he says that it is unbonded tendon. Okay, unbonded tendon. Unbonded tendon. What does it mean? Unbonded tendon means it is a post-tensioned beam. Okay, bonded and unbonded case will come under only post-tension beam only, not in pre-tension beam. It is not particularly mentioned whether it is post-tension and pre-tensioned. Okay, you need to identify by this condition whether bonded or unbonded. Okay, if he says post-tensioned with bonded, then also it will be post-tension. If he says only unbonded, that is also understood as post-tensioned only. Okay, because there is no unbonded and bonded condition in case of pre-tensioned beam. Okay, so it is unbonded tendon means it is nothing but post-tensioned beam. Okay, which is nothing but type is post-tensioned. Post-tensioned. Okay, unbonded tendon with cross-sectional area of 7,000 mm square that I have written here. And one more thing, the tendons are parabolic with an eccentricity of 1,220 mm at the center of the span. Eccentricity of the tendon is how much? 1,220 mm. Let me write the tendons here. Okay, the eccentricity of the tendons, okay, is given as 1,220 mm. Eccentricity of the tendons is given as 1,220 mm. Okay. Then FCK is given as 45 Newton per mm square. FP is given as 1,200 Newton per mm square, which is nothing but pre-stress after all the losses. See here in the problem, the depth is not given, but it is indirectly given. How it is given? Distance of centroid from the top fiber is given, and distance of pre-stressing steel or eccentricity of the pre-stressing steel from the centroidal axis is also given. Using these two data, you can assess effective depth. Correct? You can assess the effective depth. D is equal to how much it will be? 580 plus 1,220. Okay. How much you will get effective depth? If you work out the answer, it is 1,800 mm. Okay. It is directly not given. Indirectly it is given. Okay. Eccentricity of the cable is given. Depth of central axis from the top fiber is given. By using both the data, you can work out the effective depth. Below you can write effective depth. Effective depth D is equal to 580 plus 1,220 is equal to 1,800 mm. Okay. Now also write rest of the data. What is that? FPE, FCK. FCK is given as 45 Newton per mm square. FCK is equal to 45 Newton per mm square, and FPE is given as 1,220. Sorry, 1,200 mm square. 1,200 Newton per mm square. Okay. These are all given data. The question is to find ultimate flexural strength. Okay. Now, as the section is a plane section or I section, we have to make a certain assumption. We have to make some assumption. So we can assume either the depth of neutral axis lies within the flange or depth of neutral axis lies within the web. Okay. and I will give you a small hint how to which one to be assumed first. Okay, in the previous case I have assumed depth of neutral axis lies within the flange. Okay, so in this case what I will do is I will assume depth of neutral axis lies within the web. Okay, why I will assume the depth of neutral axis lies within the web for this particular problem is just if you compare the overall depth of the I section. Okay, if you compare the overall depth of the I section, here it is very high, 1800 mm, 1.8 meter depth is the effective depth of the I section. When depth increases, definitely there will be shift of the neutral axis into the web from the flange. So on that basis, I will assume depth of neutral axis lies within the web. In the previous problem, if you observe students, overall depth is little less, only 320 mm. Okay, keeping in view of that mind, what I assumed I assumed as the depth of neutral axis lies within the flange. So in this way, you can roughly decide, not exactly, you can roughly decide which case to be assumed. Okay, there is no problem if assumption goes wrong. Okay, you can perform the calculations in another step by assuming in another way. That is also fine. Okay. So keeping in view of overall depth, you can decide which one is to be assumed. Okay, now for this problem, I'll assume depth of neutral axis lies within the web. Step one. Step one. Assume neutral axis lies within the web. Neutral axis lies within the web. That is, depth of neutral axis lies within the web means it is greater than 360 mm. Nothing but DF. Okay. Now, when you assume depth of neutral axis lies within the web, what is the procedure? Let me go to the theory part. This is the formula which we have to use. Procedure is to find first area of pre-stressing required for plane section, area of pre-stressing steel required for web section, then finding the ratio APW FP by BWD into FCK. Okay. Now I'll take this formula AP is equal to APW plus APF. AP is equal to overall pre-stressing steel is equal to area pre-stressing required for flange plus area pre-stressing steel required for web. Okay. And this formula for APF is known here 0.45 FCK BF minus BW into DF by FP. Let me take the formula. APF is equal to, we know that APF is equal to 0.45 FCK into BF minus BW into DF by FP. See, this formula is not there in the codebook. You need to remember, students. Okay, if the depth of neutral axis lies within the flange, you need to remember the formula of APF and as well as this formula of moment of resistance. This formula. Okay. Now APF is equal to 0.45 FCK is given as 45 Newton per mm square. 45 Newton per mm square into width of flange. How much it is given? 1200 minus width of web is given as 240 into depth of flange divided by FP. Depth of flange is 360 divided by FP is how much it is given? FP is it given? As it is given as 1200. FP, it is final precious after the losses 1200. Let us take 1200. If it is not given, you can assume it as 1600. Okay. But here in this problem, after the losses, he has given the pre-stress, that is 1200 per mm square. By this, you'll get the value of APF. Calculate the answer and check your answer. It is 5832 mm square. 5832 mm square. Okay. Now in this equation, you substitute area of pre-stressing steel AP is 7000 mm square. 7000 is equal to APF is 5832 plus APW. By this, you'll get APW. APW, if you calculate, you'll get the answer as 1168 mm square. 1168 mm square. Okay. Now, we assume depth of total axis lies within the web and it is given unbonded tendon. Unbonded tendon means table 12. Table number 12. You need to refer table number 12, and with respect to post tension case, this table belongs to post tension case only. It is okay. Here it is clearly written unbonded post tension beam. Okay. Now we need to calculate this ratio APFP divided by BDFCK. Step 2. The ratio from table 12 for unbounded condition. Now APFP by BDFCK. Okay. What we have assumed? We have assumed depth of neutral axis lies within the web. Now you need to substitute the corresponding width of web only, BW into DFCK. Okay. So AP is 1168, correct? Area pre-stressing steel. One more thing, APW. Okay, we have assumed the depth of neutral axis lies within the web. Then this formula can be rewritten as APW FP divided by BWD FCK. 1168 is APW into FP is given as 1200 whole divided by BW into D into FCK. BW width of web is 240 into effective depth 1800 into FCK is given as 45. Okay, you will get this ratio as 0.072. Okay, then what else is needed to calculate the XU by D ratio? You need effective span to effective depth ratio. That also we calculate, and effective span L by D, nothing but effective span to effective depth. Effective depth is equal to effective span. How much it is given? 40 meter, 40,000 mm. Effective depth is 1800 mm. 40,000 divided by 1800. By this, we'll get this ratio as 22.22. Okay, 22.22. Now, referring the table 12, we can obtain the value of XU by D. We can obtain the value of XU by D. Okay. Now just refer to this ratio. It is 0.072. 0.072 means 0.072 means it will fall in between 0.05 and 0.10. Okay, APW into FP BWD FCK value is 0.072, which will fall between 0.05 and 0.10. Okay. And LYD ratio 22.22. L by D ratio is 22.22 means it will fall in between 20 and 30. 20 and 30. Okay. Which means what you have to do is you have to obtain the XU by D corresponding to 22.2 when AP by FP BDFCK is 0.05. Then you have to obtain value of XU by D corresponding to 22.22 when AP by BDFCK is 0.1. Then in one more step, further doing interpolation, you need to obtain the value of XU by D corresponding to FP by BDFCK is equal to 0.072. So here we have to do multiple interpolations to get the exact answer. Okay. Now from table 12, okay, write in table form. See, in the row, I'll take APW FP divided by PW into D into FCK. Okay. Now we want this ratio is how much? It is 0.072. 0.072. We have the value for 0.05 and 0.10. Okay, we have the value for 0.05 and 0.10. But we want the value for how much? 0.072. 0.072. Okay. Now here in the columns, I'll take L by D ratio. L by D ratio, how much we have? L by D ratio we have as 22.22. We are having it as 22.22. So we have the value for 20 and we have the value for 30. Okay, we will note the values for 20 and 30 correspondingly. We will note the value for 20 and we will note the value for 30 so that we can obtain the value for 22.22. This is L by D ratio. Okay. Now at 0.05, okay, at 0.05, when L by D ratio is equal to 20, at 0.05, when L by D ratio is equal to 20, the value of XU by D is how much? 0.16. And when L by D ratio is equal to 30, 0.16. 0.16 and 0.16. Let me write the values here. 0.16 and 0.16. Similarly, when L by D ratio is equal to 0.10, okay. When L by D when AP by BDFCK is equal to 0.10, 0.10 means at this value 0.10, L by D ratio at 20 is 0.32, L by D ratio at 30 is 0.30. Let me write those values here. 0.32 and 0.30. Okay. I hope you are all understanding. At 0.05, I have written L by D, XU by D ratio corresponding to L by D is equal to 20, L by D is equal to 30, 0.16 and 0.16, 0.32 and 0.3. Okay. Now what you have to do is you interpolate between these two values. So when L by D is equal to 20, XU by D is 0.16. When L by D is equal to 30, XU by D is 0.16. Here, if you do the interpolation, you will get the same value here. You will get the same value, 0.16 only. Similarly, here you do the interpolation. Okay. When L by D is equal to 20, corresponding XU by D is 0.32. When L by D is equal to 30, corresponding XU by D is 0.30. You need to obtain the value for 22.22. If we do the interpolation, if you get the value of 22.22, Okay, if you solve for 22.22, you will get the answer as 0.3156. Okay, this 0.3156 is between the interpolation between 0.3 and 0.32, corresponding to the values of L by D 20 and 30. Okay, we have obtained the value for 22.22. Okay, now when L by D is equal to 22.22 and AP FP by BD FCK is equal to 0.5, the XU by D corresponding XU by D is 0.16. Similarly, when L by D is equal to 22.22, AP FP by BD FCK is equal to 0.10, corresponding XU by D is equal to 0.3156. Now you can obtain the value for 0.072 by interpolating between these two values. When 0.05 value 0.16, when 0.10 value is 0.3156. Similarly, you can get the value for 0.072. Final value of XU by D is 0.228. Okay. So in the notes, I have given detailed explanation, students, for this. The thing is that just 3 times you need to do the interpolation. That's it. Okay. Here I given below this table I given detailed explanation. Okay. If you got any confusion, you can go through this. Okay. We'll understand in a clear fashion. Okay. Now the final value is 0.228. XU by D is equal to, therefore, let me take that value. Therefore, XU by D is equal to 0.228. XU by D is 1800 is equal to 0.228. You can calculate the value of depth of neutral axis now. If you calculate, it is 410.4 mm. 410.4 mm. Now you can see XU is equal to depth of neutral axis 410.4 mm and the depth of flange given is 360 mm, which is greater than depth of flange, means the neutral axis lies within the web. Assumption is correct, which is greater than DF, that is 360 mm. Hence, assumption is correct. Hence, the assumption neutral axis lies within the flange is correct. Okay. Now, as the assumption is correct, now XU by D, XU depth of neutral axis is known. We also need the value of this FPU by FP value. We also need the value of FPU by FP value. So obtain the value of FPU by FP corresponding to AP FP by BD FCK is equal to 0.0. How much it is? 0.072. Here also similarly as we perform the interpolation for this obtaining this XU by D, similarly same kind of interpolation, same setup table we have to write, and we have to do the interpolation. Let me write it. Here AP WFP divided by BWDFCK. Same values here, 0.05, 0.072, 0.10. 0.05, 0.072, 0.10. Okay. Now L by D is equal to 20, 22.22, 30. L by D values 20, 22.22 and 30. Okay. Now just refer to the table. So when L by D with respect to 0.05, with respect to the 0.05. When L by D is when L by D is 20, corresponding value is 1.32. When L by D is 30, corresponding value is 1.21, 1.32 and 1.31 and 1.31. Similarly, when AP by BW FCK is 0.10, corresponding APU by AP value is 1.26. With respect to L by D is equal to 20. And 1.18 with respect to L by D ratio is equal to 31.26 and 1.18. Let me write here 1.26 and 1.18. Okay. Now we are doing interpolation between these two. Okay. If you obtain, we know the APU by AP value for L by D is equal to 20, that is 1.32. You know the value of APU by AP value for L by D is equal to 30, that is 1.31. Do the interpolation, get the value for 22.22. Get the value for 22.22. If you solve it, you will get the value as 1.295. Similarly, you do the interpolation between 1.26 and 1.18 corresponding to 22.22 L by D ratio. You will get the value as 1.24. Okay. Now for 0.05, 1.295, for 0.10, 1.24, for 0.072, you do the interpolation. After final interpolation, the final value of APU by APU that you get is 1.270. This is the final answer. Okay. Therefore, below you write it as APU by APE. APU by FPE is equal to 1.27. Okay. Therefore, FPU by FPE is given 1200. That is pre-stress after the losses FPE. That is 1200 is equal to 1.27. Therefore, FPU is equal to 1524 Newton per mm square. 1524 Newton per mm square. Okay. Now you got the value of APU, you got the value of XU. Use this formula to get the moment of resistance value. What is the formula we have for depth of neutral axis lying in the web? So this is the formula. As I said, you need to remember this formula, students. Let me copy this formula here. We know that step 3. Step 3. We know that MU is equal to FPU. I am copying the same formula, FPU into APW into D minus 0.42 XU plus FPE into APF into D minus DF by 2. This is the formula. So you can substitute everything, every parameter is known. FPU is 1524. Area of pre-stressing steel in the web, APW. How much it is? APW is 1168. 1168. Effective depth is 1800 minus 0.42 into XU. How much we got XU? 410.4 mm. 410.4 mm plus FPE is 1200 into APF. APF we have 5832 mm square. 5832 into 1800 minus depth of flange divided by 2. Depth of flange, how much it is given? 360 divided by 2. Okay. By this we will get ultimate moment of resistance, that is 1.423 into 10 power 10 Newton millimeter, or else it is 1432, sorry, 14230 into 10 power 6 Newton millimeter. In terms of kilonewton meter, mu is equal to 14230 kilonewton meter. So this is the final answer. Okay, this completes the problem. If you got any doubts at any point of calculation, you can ask. Any doubts? Okay, students. Now there is one more problem. That is problem number 7. Problem number 7. Let me show that it is not copied because I will give you as homework or the assignment. You take it. You take this problem as assignment problem. Problem number 7 and solve for it. You can refer the previous problem. Okay, it is similar to one of the previous problem. Okay, even I have given the answers. You can solve for this problem. Okay, you take this as assignment. Okay, now we'll go for solving problem number 8. I'll have to write this problem quickly. Take 1 minute time. Please keep writing the problem and write all the given data. We will solve this problem. Problem number 8. It is a problem on T section. It is a problem on T section. A pretension T section has a flange which is 300 mm wide and 200 mm thick, and the rib is 150 mm wide by 350 mm deep. Solution. T section. Let me read the diagram of a T section. .300 mm wide, width of flange, and thickness of flange DF is equal to 200 mm thick. Okay. The rib is 150 wide and 350 mm deep. BW is equal to 150 and how much it is? Depth 500 mm depth. Sorry, 350 mm depth. Depth. Okay. Effective depth of the cross section is 500 mm. If you assume this pre-stressing steel here, effective depth is given as D is equal to 500 mm. 500 mm. And AP, FCK, everything is given. Just note all the data here below. So width of flange is equal to 300 mm. Depth of flange is equal to 200 mm. Then width of web is equal to 150 mm. Then effective depth is equal to 500 mm. Then AP is given, area pre-stressing steel. How much it is given? It is given as AP is equal to 200 mm square, FCK is equal to 50 Newton per mm square. AP is equal to 200 mm square and FCK is equal to 50 Newton per mm square. Then what else is given? FP is given 1600 Newton per mm square. FP is equal to 1600 Newton per mm square. Okay. To find here also we need to find ultimate moment carrying capacity of the T section, MU. Okay. Here also we have to follow the same procedure, students. We have to assume some case. Okay. Then we have to check whether assumption is correct or wrong. If it is if the assumption is correct, and we have to proceed with finding the moment of resistance with respect to assumed case. Otherwise, we have to assume another case. Then we have to find moment of resistance. Okay. Now initially I'll assume depth of neutral axis lies within the flange. Okay. I'll assume depth of neutral axis lies within the flange. Okay. You can see depth of flange is 200 mm and effective depth is 500 mm. Little less effective depth is little less. Even here you can see depth of flange is 200 mm, almost half the effective depth. That is why on that basis, roughly I will assume neutral axis lies within the flange. Okay. Assume neutral axis lies within the flange. Okay, that is XU is less than DF. XU is less than DF. Okay. Now, what is the type of beam it is? It is a pre-tensioned T beam. Okay, pre-tensioned T beam is table 11, obviously. Okay, you need to refer table 11. Okay, pre-tensioned beam nothing but we need to refer table 11. Okay, means we have to find APFP by BDFCK. Then corresponding to that, we need to find XU by D and check whether assumption is correct or not. Same procedure here. Now table 11 from table 11 APFP by here BDFCK can be rewritten as we have assumed depth of neutral axis lies within the flange. So this can be written as APFP divided by width of flange BF into D into FCK. Okay, AP is 200, FP is 1600 divided by width of flange 300, effective depth 500 into FCK 50. If you work out the answer, you will get it as 0.04. Please check the answer. Okay. Now from table 11, you need to find corresponding XU by D with respect to AP, FP by BD, FCK value of how much? 0.04. 0.04 means it will fall in between 0.025 and 0.05. Okay. So for 0.025 for post tensioned column, XU by D is 0.054. For 0.05, the corresponding XU by D is 0.109. Let me take here XU by D from table 11. From table 11, that is pre-tensioned column. Okay. Okay. When AP into FP divided by PF DFCK is equal to 0.025, corresponding XU by D is equal to when 0.025 it is 0.054. 0.054. Okay. When the value is 0.04, sorry, when value is 0.05, corresponding value is 0.109. Corresponding XU by D is equal to 0.109. Okay, so we need the value for 0.04. Okay, we have the ratio 0.04. We want the value for 0.04. Okay. Now we can do the interpolation and get the value for 0.04. So after interpolation, okay, the corresponding XU by D that you get is 0.087. Therefore, XU by effective depth is known. 500 is equal to 0.087. By this, you'll get the depth of neutral axis as 43.5 mm. Okay. Now depth of neutral axis is 43.5 mm, which is less than depth of flange, that is 200 mm. Correct, which is less than DF, that is 200 mm. Therefore, our assumption is correct. That is, depth of neutral axis lies in the web. Hence, the assumption is correct. Okay. Now, if the depth of neutral axis lies within the flange, same formula we have to utilize. Okay, if the depth of neutral axis lies within the flange, we have to use the formula which is there in the code book only. Okay, if it is lying in the web, in the previous problem as we used the formula, that formula we have to use. Okay, same. Therefore, from page number 59 and one more data we have to find now, AP value, APU value. Okay, see if corresponding to 0.025 with respect to pre-tensioning, the APU by 0.87 AP is 1. For 0.05 also it is 1. So corresponding to the value of 0.04, you will get the one only the value. Okay, for AP FP by BFD FCK is equal to 0.04 corresponding FPU by 0.87 FP is equal to 1. Okay, 1 only it is. Now FPU by 0.87 FP is given, that is 1600 characteristic strength of the tendon 1. Therefore FPU is equal to, we will get as 1392 Newton per mm square. Okay, now you can utilize the formula from therefore from page number 59 IS 1343 1980. We have the formula for mu is equal to APU into AP into D minus 0.42 XU. Into D minus 0.42 XU. Therefore, mu is equal to APU is 1392 and AP, it is given in the problem directly 200 mm square. 200 mm square. Effective depth is given as 500 minus 0.42. What is the XU we got? XU we got it as 43.5 mm. 43.5 mm. By this, you will get the value of mu, that is 134.11 into 10 power 6 Newton millimeter. In terms of kilonewton meter, the answer is 134.11 kilonewton meter. Okay, so this completes the problem. So it is also a very simple problem. Okay, I hope it is clear for everyone. Still, if you have got any doubts, you can ask. We will end the class and we will continue in the next class. Thank you.